Welcome everyone. Today we are going to have a presentation about predictive system performance data analytics using Salesforce Wave. And my name is Jasmin Akic. I'm a member of the enterprise scale performance engineering team at Salesforce. And Samir?
Hi, my name is Samir Pilipovic. I'm the member of the same team. Our team mainly deals with large enterprise deployment on the Salesforce platform. As you can imagine, we have to often figure out things that no other team has done before. And we try to push boundaries of Salesforce, make it better, faster. And often we have to resolve really tough performance problems or scale problems, where customers try things that have never been tried before.
Yeah. Okay. So what are we going to cover today? First, I want to welcome everyone and want to say that today's session is not going deep into technical details, and almost anyone should be able to follow what we are going to present today. And this session is made for sysadmins, performance engineers, developers, and even business analysts who are dealing with predictive models and trying to implement machine learning algorithms. So today, in enterprise environments, artificial intelligence and predictive models are really important tools for everyday business decisions. So in this era of the web-based economy, borders between performance engineering and business analysis are actually melting. So if you have a web presence and you are not analyzing your system performance data, you should be doing that. You are probably missing something, as it might have a big impact on your bottom line. So understanding how these technical systems and your applications are working and how they behave is very important to address multiple issues. As Samir said, how well our applications are going to scale, what are the limits of your applications, and what are the reliability issues of your applications. So today we are going to cover multiple parts. One is going to be introduction to actual application of machine learning to system performance data, and then we are going to have demos after each part, and at the end we are going to show you how actually all the data can be visualized using Salesforce Wave. And there are going to be 3 demos during the presentation. This is just forward-looking statement, but we are not planning to say anything that is related to the Salesforce software development plans. And let's see, what are the challenges in performance analytics today? We are trying to walk through the process, essentially through the trail that can lead from raw data that you can collect from a system and that you can understand and analyze those data, how to make a prediction on those data using machine learning algorithms, how you can detect anomalies and exceptions on your current system performance data. So essentially you're trying to find out if something is wrong with your system. Does your system behave as it should be? Now the big question is, what is that it should be? We might have some implicit expectations how your system needs to respond, but we can actually see how we can learn and how we can find out real patterns in a system utilization data. We would like to generate alerts whenever something bad happens, right? And we would like to see what is the impact of a problem or anomaly that you might find out. And eventually, we want to visualize data to provide some visual interpretation of predictive data and how to deliver data to other teams. So if you need to deliver data to your executives, most likely they are not going to use the same tools that you are using to analyze system performance data. So we start from very basic raw data that you might collect from your systems. And if you look at this chart, you will see that your system can show some periodic patterns. So these patterns could be daily, could be weekly. You see that, for example, Monday and Friday are not the same, and weekend specifically not the same. You're trying to find out if there are some long-running trends, so that if your system performance data show that it is slowly increasing the load, so that you are trying to find out what is the actual rate of the increase, and you are also trying to find out, if you are monitoring the load, if there is any exception, if something is not as it is typical for a particular data shape for a particular metric. So Samir is now going to do the demo to show you how real data look like.
Out of this screen to show you something else. So, I mean, this method that we're going to describe here is not only applicable to performance data. You can use it for various other data that have some patterns or repetitions. So these are the data that we started with, nothing fancy. And on top of that, the last most right 4 columns, we threw them away. These data we collected from Splunk, and it basically has a timestamp and the count of API calls in our case. So nothing really fancy. But when you start with something like this, you maybe one day we'll be able to ask Alex or Cortana and say, hey, what do you think of my data? Are they any useful? So we're not there yet. So you have to visualize your data to see if there are any patterns, because humans are still better at that than computers. Some data might be just too random. There is not much really you can do at this point. Maybe sometimes in the future we will be better equipped to deal with such data too. But for now, we're dealing with somewhat periodic data. So even for a first look at data, we used Wave, and I can show you. I mean, why we used Wave? You can use any kind of visualization tool, but in this case, we have a beautiful tool from Salesforce, and it's mostly used for business data, but we wanted to show you can use it also to analyze your performance data. So this is our input data when we took a count and timestamp as input. We'll show you a little bit later how we modified further data to get a better handle on use machine learning for it. So you can see there are certain patterns in the data. Data represent 2 months of API calls per hourly. And so each of these ones represent a day. And you can see it pretty much repeats, with some exceptions. As you can notice here, you can see on Friday afternoon, people are starting to, work a little bit less. Somehow my API account goes down, and again, here's a Friday afternoon, here's a Friday afternoon. So as soon as we looked at this, it was like, okay, this looks like beautiful data to do some machine learning on it. And another thing is we played with how much input data we actually need. Is it like 10 days, month, 2 months? Eventually we came to the conclusion that 2 months will be enough for us to train our model to give us some predictions for future. If you take too little data, you might miss some exceptions that might be hidden in some long-term periods. So for us, it turned out 2 months was pretty good. Because as I said, for example, here, this is Monday. As you can see, all Mondays look like this, except this one. If we, by pure accident, missed that period of time where we had this one exception, we wouldn't be able to catch it. So once we collected this data, we used standard Salesforce APIs to load data into Wave. They're available for download. We'll give you a full list of links where you can get all these tools that we used. And on top of that, everything that we do here will be in GitHub. You can download it from there. We will not have time to go into the code, but you can look at the code and use the same way that pretty much same code to experiment on your own. Everything is open and downloadable, so you can play with that side. So after we got these data, we used them as a training data to train our model. So what happened, as I said, we realized that there are patterns in a weeks, but then, there's these exceptions. This is a Sunday. And then we realized there are also things like holidays, which turned out to be this Monday here and some other down the road. If you scroll down, you might find some more. So those are all things that we had to train our machine learning code to recognize. Otherwise, our prediction won't work in the future. So yeah, Yasmin will take it from here and talk more about rest of our process. You will probably have to skip. Yeah.
Oops.
It didn't remember where we stopped.
Yeah.
Just.
I'm sorry. Okay. So now, what can you learn actually today in this session? What is in it for you? For those of you who are system administrators or performance engineers, they can learn how to analyze and how to deliver metrics to the rest of the organization. So most likely you want to provide some valuable input to executives and other teams in the organization. Developers can learn how to actually prepare the data and how to apply machine learning to make predictions. Whether those are predictions on actual system performance data or some business metric that you have, that doesn't matter, the same methods apply. And business analysts also can learn how to apply this technique to the business data and the business metrics that you might want to analyze.
Or if you're techy, they might ask you to do it for them. So
exactly, yeah, yeah,
works.
Okay, so. There is something important in machine learning that is taking most of the time when implementing these algorithms. How to prepare, how to gather data, and how to prepare data to actually be in a good format for the machine learning, so that you can you can recognize all the patterns and events in your input data. So usually in this example, we start with a simple timestamp. And timestamp, we can deal with the timestamp information in a simple string-based format. But that one is not good to do any kind of mathematical calculations or machine learning calculations. A little bit better than that is to convert date into a decimal date format, which is ordinal date starting from some date back in the future, and use that where we have a decimal part of the number that is actually presenting hours and minutes and seconds.
So the number at the bottom is that what we got?
Yeah,
from
that
the
is
number from the
number
daytime stamp on the top.
Yeah.
It's basically from 000.
So what can you do actually? How to get some important information from the timestamp? And in the machine learning, it is called extracting the features. So what is a feature? Feature is essentially something, some number, some value, some property that represents the object that you are analyzing. So if you are using timestamp, we will see that timestamp has different components. For example, it has a year, it has a month, it has a day, hour, minute, second, which day in a week it is, which week in a year, which quarter, might be calendar quarter, might be fiscal quarter that might be coming from some corporate calendar. And essentially you are trying to get all these components. And this technique is very similar to those who did some work in the data warehousing. So in the data warehousing and the dimensional modeling that Ralph Kimball defined, he described how we define these dimensions. And this looks, timestamp components look pretty much like attributes that you have in a dimensional model for the time dimension. But for the purpose of algorithm that we are trying to show you today, we are trying to extract from the timestamps some features that are essentially binary in nature. They just say it is true or false, it is 0 or 1. And we call those binary features, and those are very simple fields or attributes that you can collect from a timestamp. So if you have a timestamp, you can collect information if that day is a Monday, if it is a Tuesday, if it is a Sunday, for example, which hour in a day it is. That are a little more complicated, which are actually telling whether what is hour in a week. So it tells you it is 7th hour on Monday, and so on. So by using this approach, you essentially end up with a large number of features and large number of input values to your algorithm. And in this case, it is probably close to 200 of those features. So you will see that later that it looks like some sparse matrix, with a lot of zeros, and just occasionally you see number 1. And those are binary features that we are going to use using this algorithm. Also, just to give you a quick note, we could actually, in addition to those features, we could use some functions, mathematical functions, but we would like not to go there today. We think that doing some very heavy mathematical modeling on a data like this actually doesn't produce the optimal result. And let's go to the next slide. So to implement predictions for the data that we have today. So the basic question is, for example, if we have this training data, what should be the value of my metric right now? So what is my prediction that value of the metric should be 2 p.m. today? And whether that value is close to the observed value that you collect from the system, or it is different. So, that is the basic idea that we are trying to do. So we are trying to use a linear regression model, and that linear regression is essentially a pretty old algorithm, but that is commonly used to predict a value of a certain metric. So if you are trying to say, what is going to be value of, let's say, my sales today, you might actually use a linear regression to give answer to that question. So we analyzed 3 different models that are all based on linear regression, just the input data are different. A linear regression essentially is trying to build a formula. So what is behind some mathematics? It is trying to build a formula that takes all these input values, features, and essentially once it generates the formula, you simply provide your current input values for this moment, for example, timestamp information, and it will give you prediction. So the most simple one is a linear regression that we are commonly we actually expect when you say linear regression, you expect some line. In this case, this is a red line on the first graph. But linear regression is actually a very good model that you can use to model periodic patterns. So in mathematics, when you say periodic pattern, usually you think about trigonometric functions. But trigonometric functions actually are fairly complicated to do modeling. And we see that we can see that there is some similarity, but it is not the optimal match. But when we apply binary features that we discussed just on the previous slide, in that case, we see that we have a pretty good fit with the training data. So in the next part of the demo summary, we'll present actually all these models and show you how you can see how well fit your model has with the training data.
Okay. Let me go back to my part. So. Okay, so we started with, as Yasmin said, with a simple linear regression. As you can see, when we applied that method to our input data, training data, we just got a line which gave us basically pretty much average and just told us that there is some trend of our data going slightly upward. If we scroll, left and right in this, you would see that this red line is going slightly up, but it doesn't tell us much. We can't predict anything. It doesn't take into account any of the exceptions, or we can't really use it. So then we tried with as Yasmin said, we were playing with various models. We tried with the trigonometric functions to apply it against our data. You can see it fits a little bit better, but still there are still big parts where it misses. And then of course, if we come to any of the exceptions or something, our trigonometric functions really didn't work well, so we couldn't use it. Once we switched to the binary model, we applied it. But our process was iterative. We learned along. So we first didn't take into account any exceptions, holidays, weekends, things like that. So when we applied our different model, that was the last algorithm, basically a polynomial function with all these binary input fields that we took. So yes, it was much better, but for regular days. For weekends or holidays, it missed. Our prediction model missed a lot. So we still couldn't use it, saying, okay, I know what it should be 60 days from now. Once we used all the binary features, we eventually determined we need more of these. Is it Monday? Is it holiday? Is it, I don't know, 27 day in a month? We got the model that when we applied machine learning was pretty good. The blue bars are real data, and the red is a prediction. So, as you can see, it matches pretty good. Pretty good. Using 2 months of input data, we trained our model. We're using Python. You can see the code, and libraries in Python are publicly available. You can use the same libraries that we used. Somebody already wrote the code. You just plug in your numbers and plug in a little bit of your code, and it does this magic. Eventually, it produced this, which was great. I mean, we felt pretty confident that it's going to work, even for new data that we didn't use to train. So that's where Yasmin now is going to explain what we did next. Sorry, just switch to full screen.
All right.
Next slide. Next slide.
Okay. So now you saw that the last model that we built using binary features did show a very good match with the training data. But the question is, how good match it is? Can you really measure the quality of your model? So idea is that if you have multiple models and then you try to improve the model, when do you stop? So you're trying to define something that is a measure of the quality of the model. And in the linear regression, it is very simple to generate something called the score, which is based on some mathematical standard deviation. But any linear regression model or tool that you're trying to use will give you that score. And so the score actually defines what is the difference between predicted value and a real observed value. And you are trying to see, whether those differences are significant or not. So the score value can be between 0 and 1, and we try to generate the score on both training data and the test data. Training data, those that we use to build the model, and test data, those that we are trying to test. It could be even now. You could say, oh, let me see what is prediction. You collect some business metric from your system, and then you calculate prediction, and then you can say, oh, how well it matches, these two values match. So the score could be valued from 0 to 1. 0 means that there is essentially no match between the model and the data. It is the same as you would calculate average value, for example. Then we tried to check other models and see how well they match the training data, and we see that it goes, trigonometric has 0.72, let's say 72% match, and different models based on the binary data show us that we have 82, 92, and 95%. The last one actually includes information, binary features that tell, for example, is my measure collected on a holiday? If it is on a holiday, depending also on a holiday type, might be lower than what is expected, or might be these what they call strong days, holidays that have a much higher, for example, web traffic, like Black Friday, maybe Christmas, and so on. So we see that we have a pretty good match, and that our numbers stopped growing. So we say, oh, now we have a model that has a pretty good match, and we can go ahead and apply it to the test data. In this case, we see that test data match pretty well for the prediction that includes Sundays and holidays. So that is about 95%. And the real, what is the real measure of the quality is difference between the training score and the test score. If difference between the training score and the test score is small, that means that you have a good model. If you have a good training score but low test score, that means you have a case of what they call overfitting of the model. So you are building the model that fits training data but doesn't have a real value when you apply it to the test data. So when we visualize prediction with the training data, this is what it shows. The red line shows the prediction, and the blue lines actually real data. So we see that it matches pretty well.
Yeah, I can show you actually the actual now with. So after we took our training model and applied it to new data that we continuously kept extracting. And this is for the new 2 months that we didn't know what the data are going to be. You can see that it's still, as the previous shows, it's still 95% match. So we could pretty safely say, okay, our model predicts it well. So if something that it doesn't match this, then there is some problem. I mean, we as a performance engineer, it's always easy to detect some problem where something crashes or you have hundreds of users of calling you. But we're trying to detect some small anomalies that we don't detect normally and might go under the radar, and you're trying to catch them and see what's going on there. Hey, why this day so many people weren't that productive, or why was the throughput of data so low? So as you can see in this case, this is actual now new production data applied. We applied our algorithm, and it gave us pretty good match. So, and we used that after that to generate some alerts. We wanted to see, okay, what happens in a case if our prediction model with the actual production data doesn't match, and I want to know about that. So this is another dashboard in Wave, which we use. There are multiple ways to do this, where we expected to see if something, okay, like here, I see, okay, the bottom row of the bar chart bars is the real data, upper one is the prediction, and we see here that prediction is much higher than actual value in the production. So it's like, okay, this could be a reason to go and investigate what happened here. Why was this much lower than it normally is on this day? in this time of the year. So if you go, you can have a higher or lower here. In this case, we have much lower, actually, than it should be. So as I said, this could have some hidden problems that you normally don't detect in any other way. So in others, this is just simple dashboard. You can, raise alerts, send an email, share it with the executives or somebody and saying, hey, we have here problems that we don't know what they are. Nobody called us, but there is a problem there. You define these thresholds and say, okay, in the case something is 20% off from what it should be, what we know it normally is, let me know. So, okay. So that's okay. We're here.
Yeah.
Sorry.
Okay. So
next slide.
Yeah, this is essentially what Samir just explained, how to generate alerts and how to see the impact of a problem when it doesn't match. This is essentially just a quick overview. How do we do machine learning? How do we take training data, how we extract feature sets, build a model, validate a model? We just spoke about all these steps. And it's important to notice that it is iterative model until you find the model that is optimal for your business process. Once you find the model that is optimal, you save it and you apply it to the test data. So you take test data, you extract features, these binary features that we discussed earlier, the same way apply the model and get predictions. So this is pretty common, but very, very helpful in case when you're trying to find and compare different models. So again, the fundamental in machine learning is how to extract feature set, and this is a formal definition, but it is essentially anything that you can measure about the system that you are trying to analyze. And so what did we cover today? We covered how to develop predictive system, applying machine learning algorithms to the system performance data, how to prepare the training set, build a model, and how to predict the values, and how to measure the quality of the model. Then Samir showed you how to analyze input data and predictions to solve business needs, so that you can find the patterns, you can implement alert system, and you can visualize data using Salesforce Wave and deliver it to your audience. And for the end, these are resources that you can use as a starting point. We are providing all the scripts and these demo data on a GitHub. So all you need is just to go to the GitHub and visit and download scripts. There are some other utilities that we can recommend, Python and Scikit that we are using in this case.
Or you can use any other language. Most languages nowadays have machine learning libraries.
Yeah.
It's pretty much the same.
Yeah, you can use R or any other tool. Yeah.
Works the same way. I mean, if you follow this, if you want to play with it, just play with it.
Yeah. So we have a couple minutes left for the Q&A.
Yes, there should be somebody with a mic. We can't hear it. Oh, here it is. Sorry. I didn't know.
Thank you.
Is it on? Try.
I think so. Okay, for the performance monitoring that you were doing, the data, do you have to have the event monitoring add-on to get that data?
We extracted data from Splunk. So depends what you're talking about Salesforce?
Yes, I'm talking about the Salesforce performance data. I know y'all have an event monitoring option, and then you have MCS that's separate. I didn't know how you could get the data that you're using.
That, I don't know. We went directly for Splunk. We have access to the system data on the Splunk level, and I'm pretty sure most customers have some access to Splunk data.
As long as you can
I don't think it really matters if the event monitoring is turned on or not.
Yeah.
Because system collects continuously information in Splunk without admin turn on or off.
Yeah, as long as you can save data in Excel format or a text file then you should be able to apply algorithms like this.
Thank you.
Hey, I just got a question about the. So, you first get the data, do the machine learning, all the calculations, and produce another table with actual and predicted values, and then connect that table to Wave Analytics
Yes.
just for the visualization.
Yes.
My question is there any place to perform that Python code or R code within Salesforce platform,
No.
or you have to do that externally somewhere else, get the data into a table, just visualize it with Wave?
You do it external. I mean, it's a standalone code that you run using Python
this
libraries
is-
and your own code.
I can comment on that. The question is, where is your source data? If your source data available in Wave, then I think you could do some scripting to apply these algorithms in Wave. But most likely, your raw data coming from some logging system like Splunk or something like that. In that case, you have to apply the algorithm externally and then load data for visualization in Wave.
Thank you.
How did you do the conversion from a raw date, calendar date format to the binary? Is
That's
that
a good
part of the
question.
Python tool?
It's in the script.
Yeah.
Yeah. Scripts are
So-
available, so.
So at GitHub, you have all the scripts that all the steps that we described today. They are all available on GitHub. So you have a script that will convert timestamp and exact features from the timestamp. So there is a script, and take a look. They are very useful.
Sorry,
there is
the session was too short. We didn't have time to squeeze in that
Yeah.
part of the.
there are scripts to actually do the prediction. There are scripts to generate alerts. There is some little algorithm. How do you recognize if you should generate alert that it is not false positive, right? Things like that. So take a look. There is a lot of material there.
Yeah, one thing that we had to take into account here, there's always some noise in your data, natural data, whatever processes you're analyzing. So you have to make sure you don't, get false alerts. You can recognize what is the noise in here. That was something with, how well your model fits. So you can't really push it to maybe 99%, but will it do any good? Because sometimes then you're overfit and it won't work. So, anybody else?
Okay.
Yes.
Do you know? Whoa, sorry. Do you know if tools like this may be available on the Salesforce platform in the future?
We cannot comment on that, but what we can say is that there is a trend in the software industry to include machine learning features into the product, starting from databases, from analytical tools, and from the integration tools as well.
Who knows
So-
what Einstein will do next?
Yeah.
Did you guys consider combining the binary feature model with the trigonometric feature model?
Trigonometric. Trigonometric models we did try, but if you really wanted to get some better match, you would need to apply Fourier transform, right? So
Yeah,
if
which would be very.
yeah,
We really
So-
want to go that route.
yeah.
I mean, you could, of course. Depends on your data. Depends what you're trying to extract. So you could really go apply some heavy math on it, and get But in this case, it was not necessary.
Yeah.
So as I said, my first statement is go look at your data, because yes, Einstein is powerful, but we're still better at recognizing certain things.
Okay.
Yes. I think we are slowly running out of time. They're going to throw us out, but let's try one more question.
Thanks, sir. So I have a question about that. How could you choose the confidence interval for your data set?
How can you choose it?
Yeah.
So that's now, yeah. What is an anomaly? Is something anomaly if it goes over 3 hours? Let's say something is off for 3 hours, or for 1 day, or 1 second. It really depends on the nature of the process or a thing that you are analyzing. So, I don't know. Maybe Yasmin has more. I don't really have a ready-made formula to give you. You have to look.
But that is a good question to define what is the impact on your system.
It's a tough question.
On your
a lot of
enterprise,
theory
right?
is written about that.
Okay.
Okay.
Thanks, everybody.
Thank you.